So this is 1.4, page 20, what was it, 26? 26. So they're talking about factors, and factors are numbers that, like 2 times 5 equals 10. These are the factors of 10. And I'm going to teach you guys factorization. That's what it's called. And actually, their example here. Whoops. I actually don't care for. I think it makes it more confusing. But if you guys wanted to look at it a little bit later on your own, you can. We're just going to jump into some of the examples they have right here. And it's going to take some practice for you guys to get this down. So I'm going to start with number 1 there. It says 18. And just watch what I do. I need to think of 2 numbers, Mr. Williams, that if I multiply them together, they make 18. What do you think, Mr. Williams? Erase points. What do you think?
I think it maybe 1 times 18.
1 times 18. So you cannot, whenever you do prime factorization, you would never use 1 and the number itself. It has to be 2 other numbers. And I see lots of hands up. Mr. Patania, what do you think?
3 and 6.
Yeah, 3 and 6 would work. So I'm going to write 18 again. Is there another pair of numbers that could work? Let me pull a stick here. Let's see here. Mr. Marquardt, what's another pair of numbers that you think might work for 18? Okay. Miss Sensor's not here. Mr. Conyers, what do you think?
10 and 8.
So that's adding. We're talking about multiplication. Okay. Miss Werner, what do you think?
2 and 9.
2 and 9 would work. Okay. Now, is there a number in this pair right here that I could also factor out? Remember, you can't use 1 and the number itself. So the only 2 numbers that would work for 3 would be 1 and 3, so I can't use those. But is there 2 numbers other than the number itself and 1 that I could do with 6?
Yes.
Okay, what do you think?
3 and 2.
Okay, 2 and 3. All right, so now let's do 9. Is there any 2 numbers that would, Miss Harley, what do you think?
3 and 3.
3 and 3. Okay, now watch what happens here. I want to show you guys something. So, can't go any further with this one, can't go any further with this one, can't go any further with that one. And so, how many 2s do we have?
1, 2.
Okay, no, there's only 1 2 right there. How many 3s do we have?
3.
Okay, what's another way of saying 3 times 3?
6.
No.
3, 2.
Yeah, 3 squared. So that's the prime factorization of 18. Now, let's look and see if we would get the same thing doing it with this method. So, how many 2s do we have? We can't go any further with that, right? We can't go any further with that. We can't go any further with that. So again, how many 2s do we have? 1, 2. How many 3s do we have?
2.
Notice that they are the same. So when you do prime factorization, and if you do it correctly, there may be several different ways to factor it out, but you'll come up with the same answer. So the prime factorization for 18 is 2 times 3 squared. All right, they have another example there, the second one, number 2, and that's 24. Let me show you guys that one. Let's look at that one. So here's 24. What are two numbers, not 1 and 24? What other two numbers could we use to divide 24? Okay, Mr. Orweller.
I forgot as soon as you said.
Oh, darn it. Miss Werner.
3 and 8.
3 and 8. Can we go any further with 3? No, but we could do 8. What two numbers could we use to factor out 8?
2 and 4.
Okay. 2 and 4. Can we go any further with 2?
Yes.
No, so we're done with 2. How about the 4? Could we go any further with that?
Yes.
What would it be?
2 and 2.
Okay, nicely done. Now, so we can't go any further with 3, can't go any further with that 2, or that 2. So we're done. How many 2's are there?
3.
And so that would be written as what? Whoops.
2 to the third power.
That's right. Times what?
3.
Okay. 2 to the third power times 3. Because there's 1 3, and it's 1 3 right there. And there's 1 2 3 2's. That would be there.
I found something else that goes.
Okay, hang on. All right, so that's one way to do 24. Is there another one?
Yeah.
12.
Okay, I heard somebody say it.
12 and 2.
12 and 2, that would work. 2 and 12. Can we go any further with the 2?
No.
No, so we're done there. Mr. Conyers, the 12, how could I break that down? Ms. Gossage, how could I break that 12 down? Two numbers. What two numbers equal 12? Speak up, sweetie. Did you say 3 and 6? 2 and 6, okay. 2 and 6. Can't go any further with that 2. Can I break down the 6 again?
Yes.
To what?
2 and 3.
2 and 3. Okay. Can't go any further with that. Can't go any further with that. So how many 2's do we have?
3.
So 2 to the third times what?
3.
There we go. Again, notice it's the same thing. There's no difference.
There's one more we can do with 24.
There is one more we could do. 2, 2, 2. Okay. But I'm not going to worry about it. I'm just showing you guys there's sometimes multiple ways to factor out a number. If you can't factor out a number, that means it's prime. Who remembers the definition of a prime number? Anybody remember that? It's a number that can only be divided by 1 and itself. So let me give you an example of a prime number. How about 11? Can we divide 11 by anything other than 1 and 11? No. 2, 3, 4, none of those fit into it. So 11 is a prime number. How about 13? Is 13 prime?
Yeah.
Yeah.
Is it a lot of odd ones out of one?
No, no, there's odd numbers that are not prime, definitely. Okay. What's an odd number? It can't be divided by what? 2, right. Can we divide 15 by 2?
No.
No, we can't. So that's an odd number. But can we factor it out? Let's see. What two numbers can we use to factor out 15? Miss Ryan, what's that?
5 and 3.
Yeah, 3 and 5.
Oh, I know the one.
Can we break down the 3 anymore? No. How about the 5? Can we break down the 5 anymore?
No.
No, can't. So the factors of 15 are just simply 3 times 5. So you can factor out odd numbers. All right? But remember, prime numbers, you can't. Let's look at the last example they gave us. I think it was 51. So I'll just move it down here. 51. Is there any number that would go into 51? Some of these aren't really obvious. Let me divide 51 by 3. Let's take a look at that. How many times does 3 go into 5?
Once.
Once. What's left over?
2.
Now what?
Room there.
I think that's 7.
7.
17.
So 51, the prime factorization is what?
17.
The first step is what? 3 and
17.
17. Can we break down that 17?
Yeah.
What do you think, Mr. Orweller? Yes? No? Can't cut it in half. 2 doesn't work. 3 doesn't go into 17 evenly. 4 doesn't. 5 doesn't. So that's it. So 51, the prime factors are what? 3 times 17. Sometimes the prime factorization is just 2 numbers. But remember, it can't be 1 and itself. All right? So, here we go. They give us some other examples here. You can see how they factored out 48 2 different ways. Here's one way, and here's another way. And so they end up with 2 to the 4th times 3. Because there's what? 1, 2, 3, 4 2s, and 1 3. I've got an example 3 here. Let's take a look at that. What's the greatest perfect square that's a factor of 1,573? Do you remember what the perfect squares were?
A number
Yeah.
that can be multiplied, a number that can be multiplied by a number that itself.
Right. So is 4 a perfect square?
Yes.
Yeah.
2 and 2.
2 and 2. What's 3 and 3?
6.
9.
4 and 4.
8. 16.
5 and 5.
25.
6 and 6.
36.
7 and 7.
49.
And so I'm just going to put ... and these are examples of perfect squares. Okay. Now, here's the question. It says, what's the greatest perfect square that's a factor? And remember, all these numbers are the factors when you figure out when you factor out a number. Okay, what's the largest or the greatest perfect square that's a factor? So it says 1,575 has 3 factors other than 1 that are perfect squares. And so 3 times 3 is one example, and that's 9. They have another example that's 5 times 5, which is 25, and there's a 5 times 5. And so 3 times 5, 3 times 5 equals 15 times 15 equals 225, and that's the largest perfect square that could be a factor of 1,575. Okay. Yeah. we'll do more of those. That one's kind of tough. But anyways, let's take a look at some of these that I want you guys to do. So you guys write these down, and you can write it on your scratch paper and then transfer it later. So yeah, I want you to do 5, 6, oh wait, sorry. We're only doing,
What, are we turning these problems in?
yeah, you'll be doing these problems.
Or, I mean, are we turning them in?
On the paper you've just been writing on, no. So even problems only. So I want you guys to do 6, do 8.
What I'm asking is,
Let me finish this, thank you. Oh, actually, that's not part of your exercises. So don't worry about those. So now we'll move down to the exercises. So I want you guys to do 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Interesting. I'm not going to worry about that one. Let's go to the next page. So 26 and 28, what you do in that is that you figure out what the number would represent. So if I wrote something like 2 to the third times 3 times 4 equals something, that's what you're doing for 28 and 26. Just figure out what those factorizations represent.
Would that mean we multiply them all together?
Yeah, exactly. Scavenger hunt.
are we doing 16 and 18?
Yes.
Yeah, and do 36 and 38. So there you go. So 26, 28, 36, 38, and then the ones that I marked on the previous page. All right, I'm going to end that.